An error is simply the difference between what we measure and the actual value of something. Think of it like this. If you measure a length and it's 20.3 centimeters, but the true length is actually 20.5 centimeter, that half centimeter gap is your error. Errors come in different flavors. Systematic errors pop up from faulty instruments or incorrect methods, like a scale that's not calibrated right. Then there are random errors, which are unpredictable and can swing either way. And let's not forget gross errors, those human blunders, like misreading a scale. Now, uncertainty tells us how confident we are in our measurements. For instance, if I say something is 20.0 plus zero point 0.5 centimeter, the true length could be anywhere from 19.5 to 20.5 centimeters. To minimize errors and uncertainty, use precise instruments, take multiple readings, and always check for parallax errors. Small steps can lead to big improvements in accuracy.
Systematic errors can really throw off our measurements, often stemming from faulty instruments or incorrect procedures. Take zero error, for instance. When a scale doesn't start at zero, it skews everything. Calibration errors are similar. If we don't calibrate our tools, we might as well be guessing. On the flip side, random errors pop up unexpectedly, like a sudden gust of wind affecting a delicate reading. They can swing in either direction, making precision a challenge. And let's not forget gross errors, those human blunders like misreading a scale or jotting down the wrong number. Each type of error teaches us something valuable about the importance of accuracy in our work.